Hey guys, from today onwards, we are starting our new tutorial series on Kafka. But before we start learning, let's ask ourselves two important questions. What is Kafka and why should we need it? To answer these questions, we need to clear some terminologies related to it, right? So let's begin with the terminology first. The very first terminology is event streaming. It is made up of two words, event and streaming, right? So event is anything that happens. For example, changes any field of database table can be termed as an event. While a stream is continuous flow of data, for example, audio streaming and video streaming that we all know about. In microservice world, event streaming is the practice of capturing event, storing it to a reliable source, processing and manipulating it, and routing the event. Right. The next terminology is event streaming platform. So basically, event streaming platform is a platform where we are playing with the events. Right. So like it helps us to publish the event, it helps us to subscribe for an event, it helps us to store the event and to process it when needed. Okay. So the next terminology is data pipeline. Right. Data pipeline is responsible for communication between different systems in real-time scenarios. Like suppose, let me give you a real-life example. Okay. Suppose you have a gas cylinder, right? You have a gas cylinder and a gas stove. You need to connect them for transporting gas from cylinder to stove. How are you gonna do that? Definitely, you're gonna buy a LPG pipe and then connect it, right? Yeah. In similar analogy, data pipelines can we think of a LPG pipe, which is responsible for secure communication between systems. Just like how LPG pipe is responsible for transferring data from gas to the stove, right? So in a similar way, data pipeline is responsible for transferring data from one device, or we can say one system, to other system in the microservice architecture, right? Okay. Now we are in a position to answer the questions that we asked ourselves in very beginning of the video. The first question is, what is Kafka? So it is an open source distributed event streaming platform used by thousands of companies for high performance data pipelines. Okay. So we use Kafka to publish and subscribe to event, to store event durably, and to process the event when needed. The next question is, why should we use it? And to answer these questions, let's see why other people are using it. Other people are using it for high performance data pipelines, right? So data pipelines must be something crucial, right? Yes, it is. Let me show you some diagrams that I prepared for you guys to explain it better. Let me open draw.io first. Sorry, it is there. Okay. Before microservice architecture comes in picture, client-server architecture looked like this. We used to have a single bulky server with database attached to it. Multiple clients or users come and make some request to the server. The server receives the request, process it, and respond back to the client. This worked well for small scale project, but when the demand grows and millions of requests start coming simultaneously, the servers start bottlenecking and is unable to respond to upcoming requests. This leads to bad user experience, of course. There are some other problems as well, like debugging is hard because everything is written on the single bulky server, right? So the debugging is hard, adding new features is hard because it is taking too much effort, right? But when there is a problem, right, the solution coexists as well. So we came up with brilliant idea of microservice architecture. Okay. Here we split the single bulky server into multiple lightweight server, which we call microservices, right? This separation is based on the type of work. Let's say a login request is handled by auth service. Order request is handled by order service, and similarly payment request is handled by payment service, and so on, right? Important thing to notice here is that now each server have to do just one kind of work, and the role of root server is to only take request from the client, route it to the appropriate server, and acknowledge back to the client. So now the root server doesn't try to do everything on its own, unlike we do it earlier. Like here the server try to do everything on its own, but here doesn't. You can think of traditional client-server architecture as a street food vendor, where the vendor takes order, make food, serve it, and clean utensils. Just like the bulky server, which is doing every piece of it on its own. And this is the reason why you can't handle too many requests here. Now let's consider the microservice architecture as a well-managed restaurant where the job is distributed evenly. For each job, we have one guy or more guy, whether it's waiter, cook, or cleaning staff. And so here we can take more orders and serve them without any hassles. Does that sound good? Yes, it does. But wait, there still exists one problem here. You can see there are so many data pipelines, right? And it is required because somehow all the services are interconnected. And boy, let me tell you one thing, that these data pipeline integration are headache for us. Let me show you how. Suppose you wanna add a new service, right? You wanna add new service for some of the new features that you wanna add to your product. So how you gonna do that? Let me add a new service here. Let us call it service C. First, you need to make a connection between the root server and the new server, right? So you connect it here, and then you need to connect all the other services with this as well, right? So there are so many things to do, and that is the reason why this is a headache for us. Okay, now we have a problem of maintaining data pipeline, right? So for this, message broker like Mighty Kafka are there to help us. Let me show their architecture to you guys. Okay. And when we use Kafka, the root server just need to do three things, or you can say three simple things. The very first thing is like taking request from the client and publishing it to the Kafka broker as an event. This is the first thing. The second thing is whatever thing is published by the root server, they also need to listen to their responses. So this is the second thing, like listening to all the responses for the requested events, right? And the third thing is whenever they got the response, they need to give the response back to the client. Okay, so this is the three things that this root server just need to do now. All remaining services also do the same thing, like publish to and subscribe from Kafka only, right? So for each service we have only one data pipeline. You can see each service has only one data pipeline, right? And you can visualize Kafka as a circular belt, okay, which carry all the events published from the root server or other services, and keeps devolving with the events, right, in a circular way. For this, let me give you an example. Suppose client 1 wants to log into the system. He made a login request. The root server received the request, make an event for login, and publish the event to the Kafka broker. Now the event comes here, okay, and it start moving in a circular fashion, right? And it comes here. Now let's say service A is responsible for handling authorization related tasks like login or register. So on this service should fetch this event and process it and give the response back to the client. But let's say the service is not free here, right? This is working on some other task, okay, or you can say some other login request, and it's not free currently. So what does happen? Does this request get lost? No, it keeps rotating, keeps rotating, and in the next turn, let's say this service gets free. The request comes here, it processes the request, right, and gives the response back to the Kafka broker. Now, as root server is also subscribed to the event like that they published, like they published the login request, so it also subscribe to the response for the login request. So when we publish the response for the login request, it again, let me clear this. Okay, this published the response. It again keeps moving also, and as this is subscribed to this event, it goes here, right, and it then goes back to the client, respective client. So this is how message broker like Kafka is helping us to solve the issue that arises with microservice architecture of data pipelines. So in this way you can use Kafka to solve problem of data pipeline, right? Also now if you want to add new services, you can easily do it with Kafka. Let me show you how. Let's leave the service as G. Okay, so you want to add this service G, right? So what you have to do now, You just need to create one data pipeline with Kafka. Okay, like this. So this is so easy with Kafka, right? Unlike how we do it with traditional microservice architects with so many pipelines. So this is the answer of our second question. Why should we use Kafka, right? And that's it for today, guys. Hope I'm able to make its purpose and use cases more clear to you. If you have any queries, suggestions, or corrections, please drop a comment. Please do share this with your colleagues. We'll see you guys in the next episode. Till then, take care. Thank you.